Okay, and so going through the second paper then, this is Linear Paper 2, June 2015. Two things just to mention again: you must write a solution to every question that I answer, okay? If you don't like the question that I do, please can you put a star next to it and we will go over that in class, okay? But every single question I write, you must also write out. Star next to any question that you still don't understand once I'm finished. Okay, and the algebra page has come up first, so that's hopefully going to be nice sort of 10-ish marks for us. So to begin with, I'm going to put an arrow down, and I'm going to look for the smallest x. What's smaller, 6x or minus 4x? And the answer is minus 4x. So to get rid of minus 4x, I'm going to add 4x to each side. That's going to give me 10x plus 13 is equal to 43. The other way of writing this is that you say, let's take over this minus 4 over to the other side where it becomes add 4x. So you get 10x plus 13 equals 43. So this is method 2. And this would be method 1 that I'm doing by here. The next thing I'm going to do now is I'm going to get rid of this plus 13. So to get rid of it, I'm going to take away 13, but I've got to do that to both sides. So that tells me 10x is equal to 30. Whereas if I did it over here, I'd say take the plus 13 over to the other side, so it's going to become 10x equals 30. Okay? Or if I was to write the full solution, maybe I could say 10x equals 43, take away 13. Okay? So that would give me 10x equals 30. And then finally, I'm going to divide both sides by 10, because 10 is in front of the x. So that gives me x equals 3, whereas for this method I would say take the 10 over to the other side, it becomes a divide by 10, so we get x is equal to 30, divide by 10, so x equals 3. Whichever method you prefer, you don't have to write down both, either this one or this one. Okay, the next one, I'm going to get rid of this over 5 bit, and to get rid of an over 5, I need to times it by 5. So I get 2x is equal to, 40 times 5, 4 times 5 being 20, add the 0, will give me 200. But remember, this is a calculated paper, so you can pop that into your calculator if you like. Divide both sides by 2 now, will give me x equals 100. Okay? Now you can actually check all of these by substituting the x in as open brackets. So 2 open brackets over 5. If I go and put in 100 there, then I should get 40. Okay, so it's a way of checking. So if you want to go and put that into your calculator now, pause the video and then put that into your calculator, and the answer you should get is 40. If it isn't 40, you've done it wrong. Okay? Okay, next question. First of all, we're going to expand the brackets, so I like to draw that arrow there to help me remember to times both of those. So I'm going to get 60 minus 2x, and then the other bit remains the same. That equals 44 is exactly the same as that bit there. Okay, I can tell you what I don't like about this question. I don't like the fact that the 2x has got a minus in front of it. So I'm going to add 2x to each side. So that is going to give me 60. Now that minus 2x plus 2x is effectively going to cancel it, okay? Although I don't want to, I can leave it like that, that's fine. And that's going to give me 44 plus 2x. I'm now going to take 44 off each side. That is going to give me 16 equals 2x. And then finally, I'm going to divide both sides by 2, so I get the answer 8 equals x, which is the same thing as saying x equals 8. Okay, so this question is asking you to read through and try and understand it. It's also put a load of stuff in percentages and decimals, and I'm surprised they didn't chuck a few fractions in as well. So they're just trying to get you to understand why each of these could be compared as the best. So free flight, so that's this option here, are the best. Well, let's try and pick out why we could say they're the best. Percentage of flights arriving on time based on 30,000 flights. So they have 85%, but this place is clearly better because they have 88, and this place is even better, so they have 92. So their number of complaints per 1,000 passengers, 0.62, so that's like 62%, 0.68, 0.78. So that's our reason there then. So it's because they have should have put they in there. They have the fewest number of complaints. Okay. The next one says best to fly are the best of the three airlines because. So best to fly. So this one here. So we've already said that they're better. We've already said they're better. So it must be this one here. Number of lost suitcases per 1,000 passengers. So only 0.24. Yeah, that's the smallest reason. Okay, because they lose the smallest amount of suitcases. Okay, and then finally, the last one, so by process of elimination, GoJet, 92% because flights arrive on time. The most compared to the others. Most compared to others. Okay. Okay, so the next one says the amount, or how many of the 30,000 flights with best flight were late. Now, we're told on the previous page that 88% of those arrive on time. So there's two ways of doing this. We could either work out what 88% is of the number of flights that arrive on time and then take that away from 30,000. Or we could just say if 88% of them arrive on time, that means 12% must be late because 88% and 12% make 100%. I'm going to go with the first option. I'm going to do 88 divided by 100 times by 30,000, and I'm going to put that into my calculator and find out what I get. So 88 divided by 100 times by 30,000 gives me 26,400 flights that arrive on time. Okay, so if I do 30,000, take away, not 30, sorry, but 26,400, I'm going to get 3,600 late flights. Okay, the next one says Free Flight and GoJet both expect to carry out 500,000 passengers next month. So they both expect to do that. How many more suitcases would you expect GoJet to lose than Free Flight to lose? Okay, so we need to go and find out what their decimal amount of luggage loss is for each. Okay, so these guys were 0.36, and these guys, in fact, I'll work in a different colour, were 0.42. So that's for every. In fact, let me read the table again. Okay, so both of these numbers are to do with the amount of luggage lost per 1,000 suitcases, or 1,000 customers, sorry. So I'm going to set this up as follows. I'm going to say for Free Flight. For Free Flight, it is 0.36 suitcases per, so that's equal to 1,000 customers. I need to change that to 500,000 customers. So if I put into my calculator 500,000 divided by 1,000, that will tell me that I have times that by 500. So that means I must times this by 500, which comes to 180 suitcases. So for GoJet, we know that they lose 0.4 suitcases per 1,000 customers. So then again, I need to times that by 500, and then I need to do the same to both sides, and that gives me 500,000 customers, and that gives me 210 suitcases. But make sure you're reading the question. The question says how many more suitcases would you expect them to lose rather than Free Flight next month? So the answer is 210 subtract 180, which would be 30 more suitcases. Okay, one of our C grade topics of the week. I think we even did this as one of the ones in class. So you really should be having a go at pausing this bit of the video, trying to get it first, and then seeing what I get as my answer. Okay? Okay, so pause the video, have a go. Okay, and right, I will go through this question. It says, Lewis owns a restaurant in Austria. He has received the bill for electricity used in the last 3 months. Forget about this little amusing drawing they put here. Very funny, I know, but let's move on. It says the bill he received was €760. This was based on an estimated meter reading. And it says that he's made a note of his meter readings. That's how much the electricity costs. That's how much he has to pay per month for his standing charge. And that's how much VAT is. And it says calculate the difference between the bill Lewis was sent and what he thinks he should pay using the meter readings. So we just need to work out exactly how much he should pay. So the meter reading is now that, and it was that, and that's telling you to do the difference of those two things. So you should subtract those two numbers. So the first thing you should do is 31,008 take away 30,256, and that gives me 752. Sorry, let me undo that one. 752, and that would be units used. You don't need to go and explain all of these. So I am just so you know what they are. Okay, so I know that a unit of electricity costs €78 for 1 unit. So 752 units I would times by 0.78, and that would give me the answer in euros. So my answer is €586.56. So I've now dealt with that, and I've dealt with that bit. It says standing charge. Now they put something in bold, so make sure you read this properly. It says the standing charge for electricity is €24.40 per month. There must be a trick here somewhere. Reading the first line, it says this is for the last 3 months. So it's very important that you do 24.40 times by 3. Okay, so 24.40 times by 3 works out at being €73.20. And I put the extra decimal place on because it's money. My calculator just said 73.2. So I've dealt with that now as well. So now I need to find out what the total is for that. So the total would be that number, add the or the £586.56, which comes to €659.76. Final bit I need to do now. It says VAT is charged at 12% on all electricity bills. So I need to do 12 out of 100 times by 659.76. And that gives me an answer of, I'm going to have to round this one because it's gone more than 2dp, €79.17, so that is to 2dp. So that gives me an overall total of 659.76, gives me an overall answer of €738.93. Okay, but again, read the question. I have not done what it said. It said, calculate the difference between the bill that he was sent and what he thinks he should pay using the meter readings. So to find the difference, he got charged €760. We need to take away the 738.93, and that comes to what's that? €21.07. Just do a double check there. Yes. Okay. So that's what the difference is. Okay, next question. One of our C grade topics of the week, happy days, has come up recently. So we know that we must create a new column called midpoint, MP, and we know to grey out underneath it straight away. So the middle of 4.5 and 5, so these are quite nice numbers. And then the next column I make is called midpoint times frequency. Okay, so effectively I'm just timesing all of these numbers together. So I get 20, 12, 7 times 0 is 0, don't do that one in your head and accidentally get it wrong, and 18. Okay, the next thing we're going to do is we're going to add up all of these numbers here, add up all of these numbers here, and then we're going to do that divided by that to work out the estimated mean rainfall. So the number of days comes to 10, and the number here of the midpoint times the frequency added together comes to 64. So to work out the mean, I do 64 divided by the 10 days, and that works out at being 6.4, and that would be millimeters per day. Okay, now just do a quick double check. My answer is 6.4. That means it should be between 4.5 and 9.5, which it is. Okay, if it wasn't, say it was under 4.5, then it can't be true. Okay. Okay, then the next question says state the modal class. Now that bit's easy. We know that modal means the most often. So i.e. which class appears the most amount of times, and that answer is there. Okay, it's 4. So that belongs to 4.5 is less than r is less than 5.5. Okay. The next one says median class. So we're looking for the middle day, okay, or the middle person. Now we know that there were 10 days in total. So to work out the middle, we want to find halfway along there. So 10 divided by 2 is the 5th day. We're looking for the 5th day here. Okay, so the 5th day, we know that this would be the first 4 days up to here. So the 5th day must have been in here. So my 5th day was between 5.5 is less than r is less than 6.5. Okay, frequency polygon, you've got to know what that means. It's the polygon word that should be really standing out there. The frequency bit could be the same, but you could get frequency, group frequency diagram or a frequency polygon. A frequency polygon is telling you it is a line graph plotted at the midpoint. So 2 bits of information to learn and get repeating around your head. Polygon, frequency polygon, line graph plotted at midpoints. Okay? So first I'm plotting at 5 and 4. So let me get the pen, sorry. 5 and 4. 6 and 2, then it was 7 and 0, and then after that it was 8, 2, so 8 and 2 by there, and then 9 and 2. Okay, you now get your ruler and you literally just join up each point to the other point. Okay, so this point here to here, here to here, then up, and then just straight across. Okay, but make sure you use a ruler. If you don't, you will lose a mark. Okay, the first thing I'm going to do to this question is I'm going to start putting in this information from here onto the drawing, just so I can start to make a bit of sense of it. So I know that the area of the rectangle ABDE, so A to B to D to E, this thing here is 3,900, or I should really say 3,900 centimetres squared. I know that E to D, so E to D is 75 centimetres. And I know that D to C was 25 centimetres. Okay? Now, inadvertently, by telling me the base and the area, they have actually let me know what this thing here is. Okay? I know that the area of a rectangle formula, area rectangle, equals base times height. Now, ordinarily, I would have just written B times H. Now, the reason why I didn't do that was because it says you will be assessed on the quality of your written communication. So I'm now going to sub in those numbers. I'm going to get 3,900, which is the area of the rectangle, is equal to the base, which is just 75, not the 25. That's the whole thing going past the rectangle. And then times by the height. I don't know what the height is. So to find out what the height is, I'm going to divide both sides by 75. So 3,900 divided by 75 works out at being 52 centimetres is equal to the height. Okay? So I now know this is equal to 52 centimetres. It says, work out the length of BC. Now BC is the diagonal by here. If that's the diagonal, I know its base and I know its height. Its height is also the 52. So I'm thinking, to work that out, I've got a right angle triangle, 2 sides, I want to know a third side. That is telling me to use Pythagoras' theorem. Okay, so 2 known sides and find an unknown. Find an unknown side. Use a squared plus b squared equals, I tend to write h squared, but I think you've been taught c squared, so I'm going to stick with c squared, not to confuse anyone. So then that is 25 squared plus 52 squared. The 25 and the 52 could switch around, you could switch those completely around, it wouldn't matter at all. is equal to c squared, but the c squared must be the hypotenuse. Hence why I always tend to say a squared plus b squared equals h squared. H stands for hypotenuse, but it doesn't matter. It's fine, it still works. So then I'm putting in literally into my calculator 25 squared plus 52 squared, and that is giving me 3329 equals c squared. To get rid of that squared, I'm going to square root both sides. And the square root of that gives me 57.7 centimetres, and that would be to 1 decimal place. Okay, and that is the length of BC. Okay? Okay, and finally it says the area of the triangle ABDC. I missed that bit. I should have done that bit. Well, I shouldn't have done that bit first. I can do either or. Now, when we're talking about the area of a triangle, you need to know a formula for that as well. Area triangle is equal to the base times by the height divided by 2. So in our case, it's going to be the base, which is going to be 25. Now, the height is nothing to do with this slanted bit here. The height will always stand at a right angle. Okay, so this right angle here is giving us a big hint that this is the height, not the slant. Okay, this is irrelevant in the next calculation I'm doing, although it is very useful for other things. Okay, for instance, the perimeter. And then finally, I'm going to do 25 times 52, and I'm going to divide that answer by 2. And that gives me an answer of, so area is equal to 650 centimetres squared, area triangle. Okay, you've got to learn what the term relative frequency means, okay? The way I always describe it is probability in practice, okay? Now, what I mean by that is if I flipped a coin 2 times, I'd expect to get 1 head, then 1 tail. But relative frequency is actually going and physically flipping the coin twice and seeing, do you actually get 1 head and 1 tail? And what do you think would be the chance of that happening? It could be the case that you do get 1 head and 1 tail, but you know full well that you could also get a head and a head, or a head and a tail. Okay? So the way that we work out relative frequency, the formula we've got to know is the number, so relative frequency is equal to the number of successes over the total trials, or the total number of things that have happened. Okay, so the way that this 0.80 has been calculated is by doing 8 divided by 10. So to work out the next one, I need to do 18 divided by 20, and that is going to give me, it's going to give me 0.90, or just 0.9 would be fine here. Okay, although it says, no, it wouldn't be fine, so it says relative frequency must be recorded to 2 decimal places, so make sure you read the question. The next one is going to be 25 divided by 30, so that's going into our calculator. Okay, so I know they were checking 10 boxes every hour, so that's 10 boxes checked, 20, 30, so this must be 40, and this must be 50. So to work out the next one, I need to do 25 divided by 30, so 25 divided by 30, and I need to round these to decimal places. Now, it says on my calculator, it says 0.83 with a dot on its head. That will not get you the mark. It's wrong. Okay, the reason why it's wrong is because it's not rounded to 2 decimal places, saying that 3 carries on forever, so you can say that's got 1,000,000 decimal places if you wanted to. If you press SD on your calculator again, you'll get all those 3's appearing, and then rounding that correctly to 2 decimal places, you should get 0.83. The next one I'm going to get is 32 divided by 40. And that gives me 0.8, but remember they want it to 2 decimal places, so I need to put the 0 in. And then finally 41 divided by 50, which is 0.82. Okay, next mark, it says, can you plot the relative frequency? So we just need to go up in a nice scale here. So I would probably go up in 0.2s. I think that's what they've tried to make you do here. So 0.2, 0.4, 0.6, and then not by there, but by here it would be 0.8, and then this would be 1. So I need to plot 0.8 on 1 AM, so that's by here. I then need to plot 0.9, so that would be halfway in between. 0.83, so I need to go and work out the scale here. So I know I've gone up total of 0.2 in 10 little squares. So I divide that by 10, which gives me 0.02. So each one little square is worth 0.02. So this would be 0.8, this would be 0.82, this would be 0.84, so 0.83 would be bang in the middle by there. Okay, and the next one, 0.8, that's much nicer to plot. And then finally, 0.82, so just one little square up. It says, a box of peaches is selected at random. What is the best estimate of the probability that the box contains exactly 8 peaches? You need to know this definition about relative frequency. Relative frequency equals best for more counts, or more trials, I'm going to say. Okay, so the best probability is the one where I've done the most amount of trials. I've checked 50 boxes here, I've only checked 10 here, and although they're pretty similar, this one's the best one because I've done the most amount. Okay, so my answer would just be 0.82, 50 boxes checked. Okay, you wouldn't need to put that bit in brackets, but that's the reason why. Okay, to answer this question, I need to know the following formula. Small multiplied by the scale factor is equal to the large. So I need to find two lines that are exactly the same where I'm told both numbers so that I can find out what the scale factor is. So if I look here, 3.5 and x, so I don't know both numbers. Here, y and 3.04, so I don't know both the numbers. But here, going straight across, I know both the numbers. So the small one is 3.36 multiplied by the scale factor is equal to the large one, so 4.2. I'm going to divide both sides by 3.6, or 3.36 even, sorry, and I will then be able to work out what the scale factor is, and that comes to 1.25. Now what that is telling me is that to get from the small shape, I must times all the lengths by 1.25, and to change it back, I must go divided by 1.25. So to work out angle X, I'm going to do 3.5 divided by 1.25. So I've gone from here, so to get to here, I must follow this arrow, and I must divide by 1.25, and that answer comes to 2.8 centimetres. And I'm then going to state X equals 2.8 centimetres. Then I'm going to do exactly the same to find out what y is, but this time, to find y, I'm on this one here, and I must be timesing by 1.25. So I'm going to do 3.04 times by 1.25, and that is equal to 3.8 centimetres. And then I'm going to state y is equal to 3.8 centimetres. To make k squared, to make k the subject of the formula, we need to get k on its own. So the first way that we're going to begin doing that is dividing both sides by 3. So we're going to get k squared is equal to m over 3. The next thing I'm going to do is get rid of the squared. So to get rid of the squared, I'm going to square root. So that's going to leave me with k is equal to the square root of m over 3. Rearrange the following formula to make g the subject. So I need to get g on its own, and the issue that I have at first is that I have g on both sides here. So what I'm going to do is I'm going to take g out as a factor. So that leaves me with e plus f inside the brackets and then h. Okay? The next thing I'm going to do is I'm going to divide by this bracket. I'm going to divide both sides by e plus f and do this one. So then I'm going to get g is equal to h over, put the divide sign in there, over e plus f. 13 million in standard form. The first thing I'd actually do before writing it in standard form is I'd write out what 13 million is. That has got 6 zeros. Okay? Now, standard form must be a number written between 1 and less than 10. So like 9.99999 would be fine, but 10 wouldn't be. Okay? So I'm going to say it's 1.3 times by 10, and how many numbers, if I did go and put a decimal point in here, how many numbers would come after that decimal? The answer is 1, 2, 3, 4, 5, 6, 7. So my answer is 10 to the power of 7. Okay, number 10, it says Jake's car has travelled a total of 31,500 miles. Correct to the nearest 100 miles. If it ever says anything like that, this is something called upper and lower bounds. To work out what the upper bound is, you must halve that number and add it on. To work out the lower bound, you must halve the number and take it off. Okay, so there's the first thing that I've seen nearest, and I can see another one here. It says to the nearest mile. If we're talking to the nearest mile, we're talking to the nearest 1 mile. So we'd then halve that and get 0.5 miles. The next thing I'm going to do is work out the upper and lower bounds of each. Okay, so upper bound, lower bound. And the first thing I'm going to do is his distance, his car distance. And the next thing I'm going to do is say it's for each hour, so we're talking about speed. It says for each hour the car has travelled 46 miles, so it's 46 miles per hour. So distance and speed. Okay, so the upper bound of the distance would be 31,500, but I would add on the bound that I've just found. The lower bound would be 31,500 take away 50. So that one would be 31,550. This one would be 31,450. The next one is going to be the speed, and the upper bound would be 46 add 0.5, which is 46.5, and the lower bound would be 46 minus 0.5, which is 45.5. The next thing it says calculate the least number and the greatest number of hours that Jake's car could have taken to travel this distance. Give your answers correct to the nearest hour. Okay then, so to work this out, I need my triangle. So that is speed is equal to distance divided by time. And to work this out, to have the least number of hours, the least number would be the smallest number of miles that I've travelled, so the lower bound of the miles, but then the car has travelled as quickly as it possibly can, so it will always be some sort of diagonal working here and here. So, to work out the time, I'm going to do the distance divided by the speed, so that is 31,450 divided by 46.5, and that gives me an answer of 676 hours to the nearest hour. So I'm going to say rounded. To get the greatest number, or the greatest amount of time, it would be the most amount of miles I've done at the slowest possible speed. So it's going to be 31,550 divided by 45.5. So 31,450 divided by 45.5, and that comes to 691. Again, that is number I've rounded. So 691 hours rounded. Okay, and there we go. So my number of hours taken for the least would be 676, and my greatest number would be the 691. Okay. This question was written pretty badly during the exam because people misread the question. You must know a couple of things about tree diagrams before we even read the question. You must know that each single branch must add up to 1. So you're looking at 0.8 add what makes 1. So I can fill that in without actually doing too much more reading. Okay? Now, what people were doing was they're looking in the question and saying, oh yeah, 0.32, that's the answer that goes here. And that is wrong. Don't do that. It hasn't said that. Okay? The other important thing to know is that between branches, you must multiply. So when I'm told here, it says the probability of buying an apple is an independent of her buying a bowl of soup. All that means is that if she does buy an apple, it's not going to affect the chance of her buying a bowl of soup. It's not saying, oh, the apple's going to fill her up so much she doesn't want soup. It says the probability that she buys a bowl of soup and an apple is 0.32. So what I'm being told here is the following. I'm being told that she buys a bowl of soup, so I'm interested in this line here, and then she buys an apple, okay? And it's telling me that this is equal to 0.32, okay? So you can either use your calculator now to do 0.32 divided by 0.8, because it was that times something here was equal to that, or you could use your logic and say 0.8 times what must be 0.32, and the answer to that is 0.4. Now that allows us to go and find out what this answer here was. This answer must have been 0.6, because each branch must add up to 1. This is also 0.4, and this is also 0.6. So I've got 4 marks for answering something that's pretty straightforward. Just make sure you read the question. The next thing says, find the probability that Shauna does not buy, so she doesn't buy soup and she does not buy an apple. So different to last time. This time I'm saying does not buy a bowl of soup, so I'm going here, and then does not buy an apple. So the numbers I'm interested in is 0.2 and 0.6. You have got a calculator this, so whatever you do not get this question wrong. The common misconception here is to write 1.2. 0.6 times by 0.2 or 0.2 times 0.6 is 0.12. Okay, so shading regions. The first one does exactly what it says on the tin. Well, I say that, we're treating all of these to have equals with to begin. Okay, so x is equal to 7, x plus y is equal to 6, and y is equal to x divided by 2. Okay, so finger on the x-axis. So the x-axis here, and then at 7. So x and 7 would be by here. You draw a straight line going through that value. So x equals 7 would be this straight line going down, but you would definitely use a ruler, not try and do it freehand. So that is x equals 7. I'm going to tick that one off to know I've plotted it. The next one is x plus y is equal to 6. So I'm going to do some working for this one by here. X plus y is equal to 6. Any two numbers that add together to give me 6. Any two numbers. So 1 add 5, 2 add 4, and 3 add 3. These are going to be my coordinates for this line. So I'm going to plot 1, 5, I'm going to plot 2, 4, and I'm going to plot 3, 3. Okay? So 1 and 5. So across the corridor, up the stairs, so 1, 5. Then 2 and 4, so by there, and then 3 and 3. Okay? Now, if I've plotted these correctly, my ruler should go through every single point. So I'm now measuring my ruler up, and it should go straight through there and there. Okay, and I'm going to write by that x plus y equals 6. Note that it goes through each 6 as well on the axes. That's not a coincidence, that's because this answer here was 6. And very finally, I am going to work out the other one, which was y is equal to x over 2, and I'm going to create an xy table for that. So x always goes up on top, y is equal to whatever x is, but then we divide it by 2. Now you can choose any numbers you wish here. You can choose 1, 2 and 3, but I'm going to work smart here and use numbers. Because I'm going to divide them by 2, I'm just going to use even numbers. So I'm going to choose 2, 4 and 6. So what is 2 divided by 2? So x was 2, 2 divided by 2 is 1. Then what is 4 divided by 2? So this time x was 4, 4 divided by 2 was 2. And finally, 6 divided by 2 is 3. So I'm now going to plot 2 and 1, 4 and 2, and 6 and 3. And I'm going to draw straight line going through those points there with my ruler, as so. And I write by that y equals x over 2. Okay. Now, if I was asked to actually go and bet all my money on where the region is, I would have said it was this bit here, because it's made a shape. It's bound to make a shape. Okay, so my first line said x must be less than or equal to 7. So I'm interested in all the numbers that are less than or equal to 7. So that's all these numbers to the left of that line. For my next line, for the y plus 6 equals, x plus y equals 6, I'm interested in all the numbers that are greater than 6. So what I go and do is I go and choose a really nice set of coordinates. I'm choosing this one here. Here, x is 0 and y is 0. Okay, so I'm going to sub that into this formula here. 0 add 0 is greater than or equal to 6. Is that true? 0 add 0 is 0. 0 is greater than 6. That's not true. So that means this point here is not the side that I want. So that means it must want all of these numbers this side of the line. Okay? And finally, again, I'm going to choose the same point here. I'm going to choose this point here. And I'm trying to work out whether, oh, actually I can't choose that point there because it's on the line. I need to actually go and work out a point that is not on the line. So any point I like, and I'm going to try and choose a really nice obvious one. I'm going to choose 2 and 2. Okay? So my question is this point the side of the line I want or is it not? So I'm subbing in 2 and 2 into here. So y is 2, x is 2. 2 is less than or equal to 2 divided by 2. 2 divided by 2 is 1. 2 is not less than 1. So I'm going to cross that because that's not true. So that means I must want this side of the line. So all my sides that are this side of the line will give me this shaded region here. Okay? It might be an idea to go and write R for region or something like that in there if you don't want to shade it in instead. Okay? Because it does also say, it says make sure that you clearly indicate the region that represents your answer. That R will definitely do that. Okay, part A, I'm going to miss. It's not the easiest calculation in the world, but part B is super easy, and you should not ever let the fact that you cannot do part A stop you from attempting part B, okay? The big giveaway here is it says answers correct 2 decimal places. You should be scooting back now to the second page and having a look at the quadratic formula. I'm going to write down what it says on the front page so we can work from it from here. It says minus b plus or minus b squared minus 4ac all over 2a. You are now going to write out a equals, b equals, and c equals. A equals 2. B equals plus 6, or just 6. C equals minus 59. The next thing you are going to do is change every single thing in that quadratic formula to open brackets, okay? If you do this open brackets thing, you cannot possibly go wrong, and you will definitely pick up all the marks, so it is really worth doing. Wherever we see a B, we're going to change it to 6. So 6 goes there, 6 goes there. Wherever we see an A, we're going to change it to 2. So 2 goes there, and 2 goes there. And wherever we see a C, we're going to change it to minus 59. I'm now going to my calculator. I'm putting in all of that information except for this sign here. I'm not writing that in. I'm just going to write down for the first time plus, and then I'll use the replay button to scan back through my calculation and change it to a minus. That's what that sign means. It means once I add it on, once I take it away. So I'm going to state x equals, and I'm now putting all of that into my calculator exactly as it looks, including the brackets, and it is absolutely vital that you do that. If you don't do it, you could lose really important marks. My first answer, when I add them together, comes to x is equal to 4.13 to 2 decimal places. When I go back to my calculator using replay and subtract, my other answer is x is equal to minus 7.13 to 2 decimal places. So an easy 3 marks there. Okay, I am going to go through this one, although it is quite hard. We will go through it at some point in the lesson, and we may be able to get some marks here. Now, I quite like the sin x graph because it sort of does what it looks like. It is going to look like an S that goes through the origin. You need to know that the top is 1 and the bottom of it is minus 1. They'll be looking for you to do that. And then it is an S shape that will go through there like that. Okay? And then the graph will just repeat and repeat and repeat. Now, truth be told, I've done that a little bit too long. I only need to go up to 360. Now, this one here, where it goes up to 1, that is at 90. This is 180. This would be 270. And this would be the 360. So all of this bit of the graph that I drew was just me doing a bit of overkill. I didn't need to do any of that stuff at all. Okay, so if you have drawn all of this, oh, and this bit here in the negatives I didn't need to draw either, but it helped me remember what the graph looked like. You shouldn't get marked down, providing you actually go and state what these numbers are. Okay, I'm going to try and get some of these marks, not all of them, possibly one, maybe two if we're lucky. I know that this volume is given on the second sheet. This is the volume of a cone, which is 1/3 pi r squared h. So I'm going to read the question, and it tells me that the volume of the complete box is 245 centimeters cubed. To work that out, that would be the volume of the cone, plus volume cylinder would equal 245. Now I know the volume of the cone. It is 1/3 pi r squared h, plus the volume of the cylinder would be pi r squared, which is the area of its cross section, times by its height. Now its height would be 9.6 take away 4.2, and that comes to 5.4, so times that by 5.4, and that is equal to 245. Now, truth be told, the rest of this is really, really, really hard. However, this statement here could be enough to get me 1 mark. So if I'm 1 mark away from a C and I'm able to spot out this mark here, then I've got there, so it was worth it.